Students, welcome to my YouTube channel. In this video lecture, we are going to solve the last 10 questions remaining from Great Circle chapters in 𝐃𝐞𝐻 book. So let's begin with question number 111. On a polar stereographic chart, the initial Great Circle course from Alpha to Bravo is what? So we are in the North Hemisphere and it's a polar stereographic chart. So we will have to draw the Earth with respect to the North Pole. Okay, this will be your prime meridian. This will be 60 west and this will be 60 east. So you are going from Alpha to Bravo, Western Hemisphere to Eastern Hemisphere. Both are located at on the same latitude, so let's connect them by a straight line. Now on a polar stereographic projection, the great circle is convex to the nearest pole. It's convex means it bends towards the nearest pole. Now we have to find great circle track from A to B. Now what is drumline track from A to B? We are going from West Hemisphere to East Hemisphere. So we will be flying a track of 090. Okay, so great circle track A to B will be drumline track A to B plus convergency angle. Okay, so convergency angle is this small angle here. So great circle will be this drumline plus this convergency angle. Okay, now drumline track is 090, convergency angle. What is convergency here? D long degree into sine of latitude. D long, 60 west, 60 east. So 120 degree into sine of 75. So 120 into sine 75 is 116 degrees. So convergency angle will be 116 by 2, 58. 090 plus 58 is 148. So great circle track from Alpha to Bravo is equal to 148 degrees. A straight line on a Lambert's chart for normal flight planning purposes. It's a rhumb line. It can only be a latitude. Is a great circle. Is a loxodromic line. So the correct answer is straight lines on Lambert's conformal projections are meridians of longitude. Are meridians of longitude that originate from the poles, North Pole or South Pole, whatever. Okay, now here the option, we do not have any option that has the meridians in it. Okay, but all meridians are nothing but great circles, right? A meridian and its anti-meridian together form a great circle. So it's safe to select option Charlie. A straight line on a Lambert chart for normal flight planning purposes can be a great circle. On a Lambert chart, if you're flying between 2 points which are separated by a short distance, great circle in that case can be regarded as a straight line. So option Charlie. On a direct Mercator chart, rhumb lines are represented by straight lines. Remember this. Rhumb lines are represented by straight lines. Which one of the following describes the appearance of rhumb lines except meridians on a polar stereographic chart? So just now we did this. Question number 111. Here we have this great circle track which is bending towards the North Pole or convex towards the North Pole. And this is your rhumb line. So rhumb lines are curves which are concave, bending away from the nearest pole. Okay, so the correct answer here will be appearance of rhumb lines on a polar chart. Ellipses around the pole, curves concave to the pole, curves convex to the pole, straight lines. So they are curves concave, bending away from the pole. 15. On a Lambert chart, standard parallels are so and so. Okay. and then there are 2 points. So great circle and drumline, fine. So draw this. Let's say this is your Lambert chart, 37 north, 37 and 65. So let's say this is your 37 north, 65 north. Now the parallel of origin will be the average. 65 plus 37 divided by 2, 51. So parallel of origin is 51 degree north. Let's label this standard parallel number 1, parallel of origin, standard parallel 2. Okay. Now these two positions are there. 49 degree north, 30 west, 48 degree north, 40 west. So A is here. Both are below the parallel of origin, 48 degree north. So A is here, B is here. A is 49, 30. 48, 40. Okay. Now the great circle, always remember on Lambert's conformal charts, great circles are curves which bend away from the parallel of origin. This is your parallel of origin, so great circle will bend away from that. So it will be something like this. So this is your great circle track. Okay. So great circle and rhumb lines are to the north. Now remember, now both great circle and this rhumb line are to the south below this parallel of origin, meaning they are to the south of the parallel of origin. So great circle and rhumb line are to the south. So option delta is the right answer. Polar stereographic projection showing the south pole, very important. Straight line joins 75 south, 45 east, 75 south, 25 west. Departure from position A is what? Again, similar question, but now we are in the north south hemisphere. South pole, prime meridian 0 degree, 45 east, 25 west, join them. Now the great circle track will be towards the nearest south pole like this. We are going from point A to B. So Rumline track at A, you're going from A to B like this. East hemisphere to west hemisphere. So 0, 9, 0. So Rumline track at B will be reciprocal 270. Great circle track at A will be Rumline track at A minus convergency angle. So 0, 9, 0 minus convergency angle. What is convergency here? D long 45 east plus 25 west. So 70. Sine of 75, right? So sine 75 into 70 is 67 degree 36 minutes. Convergency angle will be half of that, 33 degree 48 minutes, or approximately 34 degree, let's say. So convergency angle minus 34. So 90 minus 34 is 56. So great circle track at A is 056. Simple. Two positions plotted on a polar chart. One is 80 degree north prime meridian. Another is 70 degree north, 102 west. They are joined by straight line whose highest latitude is reached at 35 west. At point B, the true force is what? So now you will have to draw the Earth with respect to the North Pole. This is your prime meridian 0 degree, 180 degree east-west anti-meridian, 90 east, 90 west. Okay. Now first position is 80 degree north and 70 degree north. So let's say this is your 80 degree north latitude, 80 degree north latitude, and this outside circle is 70 degree north latitude, 70 degree north latitude. So 80 degree north prime meridian. So point A is somewhere here, okay, on the prime meridian. 70 degree north, 102 west, 102 west. So somewhere here, 102 west. Right? This outside circle is 70 degree north latitude, 80 degree north latitude, and north pole is 90 degree latitude. Okay, and now there is another meridian 35 west. Now this point A and B are joined by straight line. Like this. Now we have a triangle, two triangles. Let's label them. So this will be 90 degree, 90 degree. This will be 35 degree. Why 35? Because this is 35 degree west longitude. So it will be 35 with respect to prime meridian 0 degree. So this is 90, this is 35. Now this angle is 0, 102, right? So 102 degree angle. It has got divided into two parts, 35, and this remaining will be 102 minus 35, 67. So this is 90, this is 67. The remaining angle will be 23. Now next step, we have to find angle ABN, North Pole. Okay, that angle ABN. Now the direction from Bravo to the North Pole will be what direction? So going from Bravo towards the North Pole. So direction will be point Bravo to North Pole. The direction is equal to 360 or 000 degree. If you want to travel from North Pole back to point B, you will have to travel reciprocal direction 180. Okay, so this direction is 180 degree. We have to calculate this big direction. So it is made up of two parts, 180 plus 23. So angle ABN equals to 180 degree plus 23. So 180 plus 23 is 203 degree. So angle ABN is 203 degrees. So at point B, the true course is 203 degrees. This is how you do it. Next, you are traveling from one waypoint to another. What is the latitude at 025 degree west meridian? Okay, so we have done these questions many times, similar questions. Draw two meridians. Both are located at same latitude, 60 south, 30 west, 20 west. Other latitude, longitude is 25 degree west. Okay. Now we are in the south hemisphere, so the great circle track will be like this. Next thing, label it. Now the distance between these two longitudes is departure. The distance between this, now draw a triangle inside like this. Label it. This is half of departure, this side of the triangle. Measurement half of departure. This is your great circle distance, and this inside angle will be half of convergence angle. We know this latitude is 60 south. We have to find this latitude where the top of the great circle is achieved. So let's find out departure. Step 1, departure equals to rhumb line distance d long minutes into cos lat. So 30 west, 20 west, 10 degree multiplied by 60 into cos 60. 10 into 60 into cos 60 is 300 nautical miles. Half of departure equals to 300 half, that is 150 nautical miles. Convergence equals to d long in degree into sine latitude. So 10 degree into sine 60. 8 degree 39 minutes. So convergency angle half of 8 degree 39 minutes, that is equal to 4 degree 19 minutes. Now again half of convergency angle 4 degree 19 minutes divided by 2, 2 degree 9 minutes or approximately 2 degree. So let's label this diagram now. This side of the triangle is 150 nautical miles. This is 2 degree. Now let's apply tan theta. Tan of 2 degree, opposite sine is great circle distance divided by adjacent side which is 150. So great circle distance equals to 150 multiplied by tan of 2. So tan 2 into 150, 5.5 degree, uh, 5 nautical miles, approximately 5 nautical miles. Now we all know this rule that 1 minute of latitude equals to 1 nautical mile. So 5 nautical miles will be equal to how many latitudes? 5 minutes of latitude. 5 minutes of latitude. So we are at 60 degrees south. When we travel southwards, the latitude value will increase and this latitude will be equal to 60 degree 5 minutes south latitude. So this is your answer. Next. Position alpha is given, Bravo is given, distance between them is given, B is to the east of A. What is the longitude of position A? So let's say uh, both are at same latitude, east. Let's say this is your prime meridian, 0 degree. 45 degree 15 minutes east is Bravo. Bravo is to the east of A. That means A can be here or A can be in the different hemisphere also. Okay. Rhumb line distance. Now rhumb line distance equals to d long in minutes into cos of latitude. Right. So rhumb line is 350 miles divided by cos of 45. Both are located at same latitude, that is 45 degree. That is equal to d long in minutes. So 350 divided by cos 45 is 495 minutes. Divided by 60 is 8 degree 14 minutes. Okay. So the difference between position B and alpha is 8 degree 14 minutes. Position B is 45 degree 15 minutes east. So alpha will be 45 degree 15 minutes minus D long. Okay, so is equal to 37 degrees. Okay, 45 degree 15 minutes minus 8 degree 14 minutes, 37 degree 1 minute east. Okay, so it's in the eastern hemisphere. Next, position alpha, again similar question. Now the distance between them is 200. So Rumline distance equals to d log in minutes into cos of latitude. So 200 divided by cos 45. So 200, that is 282.8 or approximately 283 minutes divided by 60, 4 degree 42 minutes. Right? So Bravo is to the east of A. So let's say this is your Earth. This is your prime meridian. Bravo is here. A is to the west of it. So Bravo 45 degree 15 minutes. D long between them is very small. What is the D long? 4 degree 52 minutes. So 45 degree 15 minutes minus 4 degree 42 minutes is 40 degree 33 minutes east. So longitude of A is 40 degree 33 minutes east. Simple. So right then this brings us to the end of the lecture and also to the end of all the questions of Great Circle from chapter or textbook Keith Williams General Navigation. I hope you have understood all the 120 questions that I have answered in this series of lectures. You have learned something new. You are comfortable now solving the great circles, rhumb lines, convergency questions. Let me know if I can, how I can help you further. If you have any questions, doubts, let me know your feedback in the comment box. Subscribe if you haven't yet. Share this video lecture with your friends and hit the like button if you have liked all my video lectures. Thank you for your time.